Key to this question, this is a velocity time graph, and what we have is we have the area underneath the graph will give us the distance travelled, and where we get accelerations, these sloping lines here, the gradient will tell us the acceleration. Distances then, we know the total area is 1.5 kilometres, 1500 metres. We know that in the first section we have an area of 300 metres, that's here. So this area distance is 300 metres, and if we want the acceleration during this first 300 metres, we simply need to know the gradient of this line. Area of a triangle, half base times height, that gives us the 300. We know the base must be 20. Half base times height, 300. If the base is 20, then the gradient, the acceleration here, must be the vertical, 30, over the horizontal, 20, and that gives us 1.5 meters per second squared. There's our acceleration for the first section. To find this value, well, we know the total area is 1500. It would be nice to know the area of this central section. To do that, it's good to know the area of this last section. We know the acceleration here is 1.25. If that's the case, we know that the height drops minus 30. The time here we don't yet know. So vertical divided horizontal equals acceleration equals the gradient, and if we turn this around, t equals 30 divided by 1.25, and that will give us t equal to 24. Once we know that, we can work out the area of this little triangle, which is going to be half base times height, and that's going to be 30 times 12, and that will give us 360. So base 24, height 30, base times height and half it, 360. So area of this central section then. Total is 1500. Take away the 300 for this triangle, take away the 360 for this triangle, and we will get a total area in the middle of 840. If that's the case, then we know that the base, t, times the height of that rectangle is the distance travelled, and that will give us t equals 840 over 30, 28 seconds. And it's done. Let's look at the next part of this question, and what we have now is we have a second train, and we are told that it constantly accelerates, and then we are told that it constantly decelerates, and we know that it covers the same distance, so we know the area here is 1500 as in the first train. We also know that we have t here is 28. We know we have 20 seconds here, and we know we have 24 seconds here, which gives us a total time for the journey of 20 plus 28 plus 24, 72 seconds for the whole journey. And so if we look at the area of this triangle, then what we have is the half of the base multiplied by the height of the triangle should be the total distance travelled, and that will tell us that v has to be 1500 multiplied by 2 divided by 72, and that will give us v equals 41 2/3 meters per second.